I'm Pao Hui from the Singapore Global Network, or SGN for short, a division of the Singapore Economic Development Board. Let me just begin with a quick introduction to Tech Plus 65 before we get started proper. We're very excited to have all of you with us today. So just a matter of weeks back, we set up the Tech Plus 65 community together with a couple of passionate folks to bring together the tech community based in Singapore with other Singaporeans as well as friends of Singapore who are based overseas. And we've been immensely heartened and grateful for how supportive and receptive this community has been. It's really early days for us. Thank you all for bearing with us, but we're already on to our third virtual event. And we also saw a number of familiar names who signed up to join us tonight. And it's really, really nice to be seeing you all again. And of course, same goes to all the newcomers as well. So before I move on, please take note of our ground rules so that we can make this session fruitful for everyone. Please make sure to mute your microphones. You can submit your questions via the chat and FAQ functions. And please do participate actively by upvoting for the questions that you'd like to see answered. Tonight's event is actually really special. It's our first digital collaboration with StackX and also StackX's very first online webinar. So we're very excited to be partnering StackX today, and they've been hosting a number of very great tech meetups in Singapore. I'll have Karen Key from the team actually say a few words at this point.
Thank you, Pao Hui and the SGN team. Hi, everyone. I'm Karen from the GovTech DevRel team. Together with me today are my colleagues Alex Singrong and Lynette joining us. So GovTech, or the Government Technology Agency, is the technology implementer for government. So my colleagues Dawn and Berlin are also here today. You may approach them to find out more about what GovTech does. So as we develop many products, GovTech in the last year has placed greater emphasis on engaging a community, people like yourselves, to share some of the products that we do, gather feedback, and as we improve some of the things that we roll out for citizens and businesses. So this is done through the StackX Meetup page. You can scan the QR code here to find out more about what we're doing, as well as keep informed of the sessions that are upcoming. If I could go to the next slide. So these are some of our COVID response projects that GovTech has done. Today, specifically, we will be sharing about Spoton. So appreciate understanding if today the questions for the GovTech team can be directed on Spoton. More sessions on the other projects will be coming up soon, and we'll share it through the StackX Meetup page as well. Thank you. Go ahead.
Thank you, Karen. So moving on, we have tonight with us to moderate the session, Min Lee, who is a UX designer at GovTech. So we'll now hand the time over to Min Lee, and we hope everybody enjoys today's session and what we've lined up for you. Min Lee, please.
Hello everyone, I'm Min Lee, and I'm a UX designer in the Smart Nation Platform Solutions division of GovTech. I work on a team that is responsible for designing, testing, and building a smart district management system for the upcoming Punggol Digital District. Tonight we have with us three very distinguished speakers: Han from Lucence Diagnostics and Chinn and Jia from the GovTech team that created Spoton. And they will now introduce themselves very briefly, starting with Han.
Hi everyone, I'm Han. I'm a cancer specialist by training. I do have a PhD in molecular epidemiology. I have a strong interest in data modeling, and it's a real pleasure to be here tonight with everyone.
Good evening, I'm Chinn. I'm happy to be able to be speaking to you about something that we've been working on. I happen to be working with very talented colleagues in the Smart Nation Platform Solutions.
Hey guys, I'm Jia. I'm a code engineer. I have the honor of working with Chinn, my senior director in the Smart Nations Platform Services Group. And I'm working on robotics, drone autonomy, and all things deep learning at GovTech.
Cool, thank you very much. We'll begin the first presentation by Han now.
Perfect, lovely. So just forwarding this. Just see. Perfect. So hi everyone. So I am the founding CEO of a company, Lucence. This is a a molecular diagnostics company with offices in Singapore, California, Hong Kong, as well as Suzhou. And as mentioned, I have a background as an academic and researcher. I've worked both in the United States as well as in Singapore's A-Star. And I think the story of our company before all this happened was that we are a precision oncology company and first founded in Singapore. And today we have two central molecular diagnostics service laboratories in Singapore and Palo Alto. As a company focused on cancer, we fight cancer with a draw of blood. So as to speak, we focus on a core technology that's extremely sensitive. And the general idea is that we can pick out the needle in the haystack or the cancer signal amidst within a blood draw without the need for an invasive tissue biopsy. And that technology is a fusion of both offline and software, which is the combination of customized chemistry as well as a deep understanding of the genome through bioinformatics. So you do need both the so-called offline and online to achieve what we can do for cancer. And then COVID-19 happened, and I think never in the history of mankind has so much attention focused on medical diagnostics. And I will say that today everyone is an expert on false positives, false negatives, serology tests. And just today, Emirates announced a 10-minute free pre-flight test, like a coronavirus passport. Now, amidst all this, we are seeing tremendous challenges in the real world as supply chains go down and huge stresses are present in operations. From the humble swab to the storage media, to the medical manpower, to the PPE to do sampling, we are seeing dramatic shortages everywhere in the world. The difficulty of refrigerating samples, the challenge of cold chain means that samples get degraded, the tests are failed and therefore wasted. Within the lab, we are seeing, once again, in every lab, shortages of almost all testing materials and reagents, therefore acting as bottlenecks for almost everything we do. And scaling up offline is very different from scaling up online. There is a background story to this. When we first developed a solution to surveillance of RNA viruses. The story begins actually with the Zika outbreak several years ago. And Zika is actually a RNA virus in the same family as coronavirus. We had developed a technology then to allow for more effective collection in the community through the use of saliva collection. And I think it's very important in such a situation that the collection method be easy, non-invasive, self-collected. One can spare the use of PPE, which needs to be changed after each patient. You can imagine the value. And I think safer sample was the result. And safer stands for stabilization of the nucleic acids, which is RNA, for the virus diagnostic testing. And today, this is being deployed in the region. This is a technical diagram, and I will just say that the goal on this graphs on the left mean this is very well preserved. Graphs on the right imply that the samples are degraded. And what we are seeing here is that with the use of the technology that was invented a few years ago and modified and developed for coronavirus, we were able to achieve good stabilization so that this could be collected, transported over a period of time. It need not be chilled. And that opens up many opportunities for more effective sample collection. And you can imagine today the challenges that everyone is having out there in the community swabbing and collecting samples from hundreds of thousands of people. So I want to summarize and say I think this is the method that we see as a non-invasive sample method for the future, and perhaps for the near present, because things are changing extremely fast. When I prepared this presentation a couple of days ago, the FDA had not approved saliva testing. Today, 2 days ago, the FDA has approved saliva testing. And this is also a message that repurposing, old technology and modifying it very quickly in chemistry can work effectively. And finally, I want to say this is an offline enhanced chemistry solution. It opens up many opportunities for online work. And I would love to work with GovTech or interested software engineers, because what this means is opens up the opportunities for a decentralized, possibly home testing. And of course, a lot of work needs to be done and to validate, to generate evidence, but this is certainly an idea which I think would be very exciting to work with the right community in the public sector. So thank you all very much for your time.
Thank you very much, Han, for your sharing. Now we will kickstart our Q&A session. Maybe to start off with a very easy question, for those of us who can't really remember our A-level chemistry, RNA stands for ribonucleic acid, right?
That's correct. I want to use the analogy where DNA is the cake recipe.
Right.
Okay? And RNA is the cake batter. Right? So the RNA is the outcome of following the recipe.
I see.
Right?
Okay.
And the final baked cake is the protein, which is the real thing which makes sense to a person. So you have three parts, and understanding the big picture requires an understanding of the recipe, the cake batter, and the final product.
Right. Cool. Thank you. Like you mentioned that there was a very quick response that your company was able to do in response to some of the policy changes. Could you explain a little bit about the development journey of the test kit from maybe from the start? Like, how do you come up with this idea, and then how did you go about going from this idea into testing and then finally into production?
Absolutely. And this is a story that, as mentioned, first started during the Zika outbreak. And at that time, if all of you remember, this began in the northeast of Singapore in a residential community. And there were difficulties in trying to understand how could people go around this area. It was near Simon Road, to actually find out where and whom had Zika. So we developed the idea where people could go around the area and non-invasively collect saliva instead of having to do unpleasant procedures. And that was when the seed of the idea began. Subsequently, this technology was licensed from A-Star, and that was my own lab in A-Star, of course. And we did a spin-off company to focus on cancer. We, as a company, we have always looked at the cancer and cancer-causing viruses together, like hepatitis B, hepatitis C. And I think it wasn't too far also of a stretch to look at other types of viruses as well. And I think a lot of the technology, we are very skilled in non-invasive, ultra-sensitive technology. And repurposing that was a matter of chemistry, figuring out how to scale up production. That's also a very industrial question. And I think I want to say that I really appreciate that the close collaborations that I have and I continue to have with A-Star, which is Singapore's leading public sector research agency. I see it as the ability to work with the strengths of industry, which is to produce and manufacture items that fulfill a need. And that really helps, we can implement these changes very, very fast.
Right, thank you. I'm sure this is also a question that is at the back of everyone's mind. How could we tell the difference between a real test kit and a fake test kit?
Well, I think we are in the midst of an infodemic where every day, you are right, we are seeing a lot of information from both public sector, marketing, and I would say that at the regulate testing is very carefully regulated in some jurisdictions, and that includes Singapore. And I would say, really, please refer to a trusted physician for this. There are different types of tests. You have the what we call the real-time PCR tests, which are still the gold standard today for detecting COVID-19. And this saliva kit supports that type of real-time PCR test. Unfortunately, those tests are all done in central labs. And so it's not like the point of care people are hoping for.
I see.
Not yet, at least. Yeah.
Okay. Okay. And then another question that everyone's probably thinking as well is, people like to compare the difference between this saliva-based tests that you have come up with and the nose swab that's been circulating around. And it's very uncomfortable, that picture that's been going around. Besides this being a more comfortable way of testing, what other differences are there?
I will say that of course, the key thing is always a great test is nothing without a good sample. And really the sampling method and how it's transported to the lab, that's something which a lot of people don't actually see. Today, the FDA has approved saliva testing. And so there is, in the early data, very strong concordance, which is to say that it's very, very close. In that particular study, it's actually reported as 100%, similarity. Now, I would say, that 100% really needs to be validated again, but I would say there are some jurisdictions today, the Hong Kong government in particular, which uses saliva, or what they call posterior oropharyngeal saliva, also known as deep throat saliva. So the Hong Kong government does use saliva collection extensively, including for all returnees at the airport.
Right. Okay, good to know. Okay, we've got a few questions from some of the attendees. One of them is, how will predictive technology enhance efficiency in the testing process post-sample collection?
So how does predictive technology enhance efficiency in the testing process post-sample collection? I would say that ultimately, a test is meant to give information for a specific question. And predictive technology can inform different things in different ways. For whether it's, do I have COVID-19? Do I have the type of COVID-19 that's really, really, that might mutate to something else? Or am I immune to COVID-19? And I would say that today, that question, the different questions are answered in different ways. I'm assuming by predictive technology, that means the ability to pull together a lot of different types of information to make accurate predictions. I would say that type of genetic sequencing technology is most useful today for surveillance, to see if the virus is mutating to something else. And I think that's something of great concern everywhere around the world today, if this changes to something else.
Yeah. Okay, thank you very much. We have a lot of other questions, but in the interest of time, maybe we will let GovTech presentation go first, and then we will ask Han the rest of the questions later during the next Q&A. Thank you, Han.
Thank you.
Hello, so this is Chinn. I'll start to share with you our journey on Spoton. It was at the end of January when our CE, Chief Executive, sent out email imploring the team within GovTech, and we have quite a big team within GovTech, all talented engineers, to see how we can pull out from our bag of tricks what we can do to support this COVID-19 and exercise to figure out what ways we can help manage the situation that's breaking out in Singapore. So one of the things that we've been working on was on robotics and smart systems. Essentially, the team that we are involved in build solution for the smart lampposts. You can see in the picture at the back, as well as other smart devices for the sensor environment. And while we were working on the robots, and with this email that popped up, it took us a few days. Then we realized that we already had some of the parts of solution in front of us. So that's when I turned around and talked to my colleague Jia Yi and said, look, you're working on the robots, and we've been working on some of the sensor payloads that is able to do thermal scanning of the environment, and the technology is essentially right in our hands. We can do something about it. So I asked him the question, can you make this into something that we can contribute to COVID-19? So I'll let Jia Yi continue the story of how the Spoton was done in 5 days.
Thank you, Chinn. Okay, so Xingrong, could you play the video, please, real quick? It might be a bit jerky over broadband, but it's actually very smooth, I promise you. It just sort of gives you an idea what Spoton is. So you can see there's people on the screen, and there are temperature readings on each face with a bounding box. It's a very simple idea. Okay, so I'll jump right into it. So Spoton is a smart thermal scanner for fast, easy crowd temperature screening. So the problem statement is as follows. We want to be able to quickly screen a big group of individuals at a safe distance and quickly tell what the temperatures are of each person on screen. That is the general idea behind Spoton. So it's a very, very simple idea. And we also have the constraint where it has to be cheap, has to be affordable. So this solution, hardware-wise, is actually less than $1,000. So what do we do to achieve this? Well, it's a combination of the recent advances in machine learning, in particular deep learning. So we can detect up to 10, actually more faces at once in real time. The device has been calibrated and tested in the labs to be within 0.3 to 0.5 degrees Celsius of accuracy. And we can screen within 2 meters of detection range, which means it's a safe thing for temperature detection. If you were to say, for example, point a thermal gun at a person, you would have to be a lot closer. So that is also a good a positive in terms of safety. It is not affected by masks, hats, or headdresses. We've tested this out. Of course, if you cover your entire face, then it won't be able to detect it. But there is some amount of robustness in the system. Crucially, because it actually tracks your human face, it is not confused if you were to say carry a hot or cold drink in your hand, especially a hot drink. In a lot of thermal scanning or thermal sensing solutions, they sort of track the highest temperature in the frame, if you will. So they might get confused by such objects. But of course, again, I want to emphasize it's not perfect. If you hold a hot drink up to your face, yes, then it would probably think you have a fever. Now, on the upper right-hand side of the screen, you'll see the icons which represent the conditions of a person. So typically you're green, that means you're fine. If it's red, that means you have possibly high temperature, fever, that sort of thing. We have added additional features as well. So there's alarms, emails, and SMS alerts. That's actually rolled out for the official version. So the system itself is extremely compact. It combines an RGBD camera with a low-cost thermal sensor, and it can be deployed both indoors and outdoors. And typically we mount it on a tripod. So this is the general idea behind it. Next. Now, we actually got the solution up and running in 5 days. So how do we do it? I'm a big proponent of native code. I think we have to write, high performance, reliable code, preferably in my favorite language, C++. But given the constraints of the time, we had to do a hybrid approach. So a lot of the layers were written, the top layers, the GUI stuff was written in Python, a lot of the application logic. But of course, the core compute was done in C++, especially more than C++ 14 and 17. So that's like smart pointers, lambdas, move semantics, futures, coroutines, that sort of thing. So that also ensures memory safety, high performance, and also C++ has the notion of zero cost abstraction, which we all love. We use PyBind 11 to basically wrap the functions and expose it from C++ to Python. So basically, it gives C++ objects the notion of reflection, which means that in Python, you can easily introspect it and call the C++ objects just like how you would like a regular Python object. So that's how we got over the performance hurdles, but at the same time, we could rapidly develop this application. Next. So the core part of it is we also employ a lot of deep learning. One of it is actually a very lightweight face detector. So essentially, the neural network, the inference part is done in real time on the cloud, sorry, on the edge, not on the edge, on device. So at every frame, we run inference. It takes the RGB frame, it sucks it in, and then runs the whole inference path, forward pass. It gives us the all the bounding boxes of the faces, and then we fuse that. Can we go to the next slide, please? And then we fuse that together with a couple of basic computer vision algorithms. So we actually fuse the thermal sensor input with the RGBD, and then with the face detected results from the deep neural network, and then you basically get Spoton. So that's the general idea. It's not rocket science. Obviously, the devil's in the details, which is where the software engineering comes in. So quite a bit of time was spent optimizing it in various places. And also, the reason why we do deep neural nets for this sort of thing is because, as you know, there's other more traditional computer vision algorithms for face detection. They're actually not as accurate, but more crucially, even for the ones that are, neural nets have one big advantage, provided you know what you're doing. They are constant time evaluation, which is a big deal. That actually helps you a lot for runtime performance. And then we have added additional features as well. There's like smart auto calibration, so it'll automatically calibrate the system based on room temperature readings. So a lot of other nice to haves which were added into the system later on. Next. So here is the general workflow of Spoton. First, you deploy the device. It does mass temperature screening. If an individual, group of individuals have a higher preset temperature of, say, 37.5 degrees Celsius, it triggers an alarm. It will send an SMS, it will send email. But at the same time, if there's people on site, then in close proximity, but from a safe distance, appropriate action can be taken. So I apologize for the background noise. But in general, so Spoton actually allows, it's a smart way of detecting human faces, so it doesn't get confused. It's safe, as I mentioned. It's also very convenient, and we have deployed it in both outdoor and indoor environments. Next. So we've deployed it in multiple places already. NTUC Downtown East is one of them, HDB Hub, MINDEF, JTC, IOC, and we're actually deploying a lot more. All our units are actually all fully booked, and we are very busy these days deploying these very lightweight temperature sensors everywhere to help fight COVID-19. And as I said, the additional features like SMS and email alerts have also been rolled in for the next release, which is, I think, coming up this Friday. Next. So upcoming work, the device is not limited to just face, temperature screening per face. We're adding more involved, higher compute stuff as well. So one of them is high quality, again, real time crowd density estimation. So we heavily rely on deep learning, but in addition to that, this time the whole framework is entirely C++ based. It's a client-server architecture. So this actually means that we can deploy the solution anywhere. We can deploy on a robot, we can deploy on a static platform, and we can have a client that streams in real time all the results through WebSocket, so it's bidirectional, and also message pack. So the whole thing is very compact because we use binary serialization. So it's designed for performance. We can deploy anywhere, anytime. much more conveniently than the previous solution, which we're also improving as well. So this is the general work coming up, human density estimation. And it expands upon the original device's functionality and versatility. So that's basically it. Thank you for attending this talk.
Okay, thank you very much, Jia and Chinn, for that wonderful sharing. We're gonna go into the Q&A section for GovTech now. I'm gonna start off with a few easier questions, I think. One of the amazing things is how the team managed to pull together this solution in just 5 days. I'm sure at the back of everyone's mind is, how did you manage to do this?
So I just want to share that 5 days is when they actually start work, from the time I said, well, Jia, maybe we can contribute something. And so the team went off and clobbered something together. But actually there was a lot of work already done in the background, where Jia was building a digital operations smart system platform to manage the sensor payloads that are going to be put both on static environment as well as robot environment. So basically static and mobile environment. So a lot of that framework that was done was already in place by GRE, and that allowed a lot of control between multiple systems. And so one of the key things is actually building on the foundations in which that were already available, and then the agility for the engineering team to then think out of the box and figure out, well, given this situation, maybe we can put a Lipton 3.5 and from FLIR, and then they're going to, and then went out source for the PCB board to put that FLIR on, which is a pure thermal 2 PCB, and then they hunted for the Realcense to give the RGB, and which is a Realcense D435. So this kind of components, the team started sourcing together, and the engineering team was able to take the stuff they were working on, and as Jia has mentioned, and stitch all of that together. And that stitching it together wasn't something that was easy. And I'll let Jia share a little bit about some of the heartaches and some of the triumphs along that 5 days. Jia.
Oh, thanks, Chinn. Okay. Yeah. So 5 days is a short. It's either a really short time or it's just enough, depending on how fast you code. That's all I'll say. But okay. Let me answer more of the technical questions. Some very interesting questions. So one of the questions is the inference performed at the edge or the back end? All the inference is performed on the device on the edge. That was the hard requirement. Because if the actual, and Chinn will agree with me on this, the recent trend in the past actually 5 years is we're moving a lot of the compute back to the edge. There's a huge advantage of this. One of them is if you move compute to the edge, it actually makes the system more resilient. Having on the cloud is great, well, at a cost of actually latency. And the other issue is also you're sort of dependent on that connection to the cloud. If that thing goes down for whatever reason, then everything you have is screwed. Having it on the edge actually means all these tiny devices or platforms, if you will, have their own ability to keep functioning even after, say, a central part of it goes down. So there's a big advantage. The other advantage, of course, is latency. You get real-time performance if you know what you're doing, which also goes on to the next topic, which is when you do it on the edge, you do stuff in native code. So C and C++ becomes very important. You don't want to do stuff with managed languages like Python, Java, C#, all that sort of thing. Question is, are you leveraging the 435 for the inference? No, the 435 is actually a RGB-D camera. It doesn't have any inference capabilities. Intel actually wants to couple that with a couple other devices. One of them is you can couple with a T265, so you can do visual SLAM. SLAM stands for simultaneous localization and mapping, which is the ability to reconstruct both the trajectory and your environment in 3D. So the 435 is designed for that sort of task. The inference code is actually our own. So, but if you're interested to know, we're actually using an inference file format called ONNX. ONNX stands for the Open Neural Network Exchange format. It's a format that was that's supported by a lot of institutions and companies, including Microsoft, Facebook, where they have this general deep neural network inference format for forward passes, of course. So you serialize it into that, and then you have all these optimized runtimes that can run and run your forward passes extremely quickly. And they have different backends. I mean, when I say backend, I don't mean the cloud. I mean backend on the edge. So they have backends for, say, OpenVINO, which I think one of the questions on the chat was that OpenVINO is Intel's acceleration framework, which runs with your compute stick too. It's this very convenient USB device that you plug it into your PC or whatever, or even Raspberry Pi, and then it will accelerate a lot of the tensor operations in real time for you. It also has backends for TensorRT. TensorRT has nothing to do with TensorFlow. It's not Google. It's actually NVIDIA's. TensorRT is NVIDIA's neural network inference acceleration framework, and it has of course acceleration backends for even generic CUDA stuff or CPU stuff. So that's something you can look into if you want to do real-time inference on the edge. I would suggest that. Yeah.
Thank you. Another question that I think is being voted as the top question right now is, what are the imaging challenges that you face, especially for real-time detection?
Well, there's quite a few challenges. So a lot of data is coming in, and so you have to, your code has to be able to deal with a lot of those the huge amounts of data that's constantly streaming in. A lot of the code is actually multi-core. So we move a lot of the processing to multiple threads. If you were to run it single-threaded, then it will kill the system. So a lot of the code has to be offloaded to multiple threads. Certain threads process the 435, certain threads process the thermal sensor, another thread does the inference. So it's not unlike, actually, if I don't know if anyone has experience, if you actually coded on, say, the PS3 back in those days, the Sony PS3 or the Xbox 360, Xbox One, you had the same experience as well. On those machines, you had, for example, on the PS3, you had a couple of very well, somewhat powerful processors running on multiple cores, and then you had a GPU. And the game you played in like console development was you would actually offload a lot of the tasks onto different cores. So some core will be doing the networking, couple cores, one core might be doing the AI, one core might be doing the physics, like doing time stepping on the rigid body solver. And then another core, like the GPU thing, is doing the rendering, but that does deferred rendering, right? So, and then the geometry processing, where before you send it in, because back then there was no geometry shader. So the geometry processing is another core. So the idea is you actually distribute all your workloads on multiple cores, so everything's saturated. This is sort of the same idea we employ for Spoton. So all the cores, if you run it, you realize, if you look at the task manager, I think all your cores are pegged, which actually allows us to achieve pretty good performance even on relatively low-end systems.
Right. What about in a circumstance where there's low visibility, low light? How does it perform? Yeah,
it's a very good question. It performs as well as the neural network can manage. So in deep learning, when you typically do when you do train, you will try to augment the training images with noise, with all kinds of bizarre scenarios that you don't see in the real world. So if, assuming you did your training right, there is some amount of robustness, or we call generalization, for the model that it can withstand. So I'm not saying it can, obviously cannot see in pitch dark, no way. And if the scene is extremely backlit, you're also in trouble. But you'll be surprised. When we were at NTUC Downtown East, one of our guys was pointing the device at a rather backlit area of NTUC, and actually did a decent job. I wouldn't say it's perfect, but it did a good enough job to at least screen most of the people coming in. Now, of course, if the situation degrades, then all bets are off. But in general, it can withstand some amount of bad lighting.
Right.
Yeah, sorry, I was going to type an answer to Doris, and then for some reason it just got killed off. So I want to apologize for that. But I want to, in her question was basically, what happens if you had more than 10 people on the screen? So it's
Oh, thanks, Chinn. So it's actually fine. The face detection network, I believe we tried it. It can go up to about 80 people. I mean, that goes beyond the limit of the what the thermal the thermal sensor can do though. So it's bounded by what the thermals can do. I think 10 is probably a good limit before the system says, hey, I'm not able to do a better job. So that's why we cap it at 10. But in theory, it can go much higher.
Do you have any ideas of how you can overcome that?
Yeah, actually, there are some crazy ideas we had. So one idea we had was to take a much more expensive, I have some talks with a couple of guys. One of them is actually he's a PhD student at Stanford right now in the artificial intelligence group. And one of the crazy ideas we were talking about was actually you would take a really high-end, extremely high-end thermal sensor with super high resolution, and then you would then use that as training with your RGB. And so you train it together. So then basically the RGB would, and remember, because Realsense has an infrared mode as well. So use infrared as an additional channel. You train it with the Realsense, so it learns exactly what the features of a good thermal image is based on RGB. And once you're done, you can throw away your expensive thermal sensor, and you just take a really cheap Realsense and you run inference in real time, and you essentially get a very high resolution thermal image from the Realsense. That's actually might be possible. Actually, quite a few people are doing that sort of thing. People are actually doing depth from monocular cameras as well. Inferring depth, which, cameras don't see depth, especially monocular cameras, not stereo, but people are training stereo cameras with monocular cameras and achieving the same thing. So that could be a possible direction, but of course that's something more in the hardcore research realm. So if we get time, we might maybe look at that in the future.
Right, okay. We've got one last question from the floor, I think, for GovTech specific questions. So for Spoton, can you still detect a face now that we're all required to wear a mask? And do you need to calibrate when you move from outdoor to indoor?
Okay, the first question is definitely yes. And Chinn will be happy to hear that because people, we were at the office today to distribute Spoton to a couple of agencies, and people were wearing masks, and it all worked. So that's a yes. We also tried with both the disposable masks and the reusable masks. So the first question is a yes. But of course, if you were to, as I said, if you cover your entire face and your eyes, then I'm sorry, yes, it will fail. I'm not claiming it's perfect. There's always cases where it'll fail. What's the second question again?
Do you need to calibrate when you move from outdoor to indoor?
Yes.
The difference in lighting, right?
Well, not the lighting, but more like the temperature. So of course, Spoton requires calibration. That's why we have a calibration tool. And so when you move to a new environment, you run our calibration tool and it will calibrate. Yes, that is correct.
Okay.
So maybe I'll add a little color to it. No pun intended, but essentially the question is if there's light. So because it's a thermal camera, you can see much in the dark because of the heat that it's emitted. So in that regard, it can also work in the night. The thing where we want to make sure why we have a Realsense is actually to infer the temperature to a specific person of interest. And so that's how what you see in our RGB is calibrated also to fix the FLIR information to that person. So there's a certain overlay that is done. That's part of the secret sauce that TIE and team has built in order to make sure that the face that you actually put a figure to is actually correctly attuned to the FLIR as well as the RGB object.
Okay, thank you very much, Chinn and Jiayi. Now we have an open Q&A session where we can ask all three speakers any other questions that you might have. So please continue to, type your questions in the Q&A box. It can be found at the bottom of the Zoom window, I think, next to the chat button. Okay, so maybe we could ask a general question that all three speakers can answer. How do you see your product continuing on after we all overcome the virus? Because, we are going to overcome COVID-19, right? And then what's going to happen to what you've developed? Maybe Han can go first.
Sure, thank you very much. I think that surveillance by governments all around the world will continue for at least 2 more years. we must not forget that during the influenza pandemic of 1918, there were 3 waves over several seasons, and the second wave was actually worse than the first wave. I think there will be a lot of attention, especially towards the end of this year, when the flu, this tends to coincide with flu waves as well, and I think at least there will be a foreseeable future for surveillance of the community. I think things are going to change. I don't think humanity will want to see this happen again.
Yeah. Okay. There's another question for Han about challenges you faced while adapting the saliva sample kit from the Zika one to the coronavirus one.
Understand. And this is definitely something we needed to do because while there are similarities, there are also differences. And the main differences lie in the type of protection that Zika and the coronavirus has against the environment. You can think of this as the viruses have different types of armor. And we need to design chemicals to penetrate that armor in different ways. And so we needed to look at the composition of our materials. I think that was one. I think beyond tweaking that, there was a second very significant challenge, and that was working, and this is still work in progress. We want to show if safer sample fulfills the ability to inactivate the virus. Now, why do we want to inactivate the virus upon collection? You can imagine the issues of safety, of leakage of a sample because stuff leaks. Along the way in the van, maybe the sample container topples over or somebody didn't screw the container completely tightly. And upon arrival in the lab, today there's extensive safety precautions. No one wants, laboratory spread. And I think a solution that can inactivate this is going to be very helpful. But the process, and this is really a challenge, the process of proving this does take a lot of time because very complex methods need to be adopted. And I think that's definitely a second very big challenge we faced in just putting together the evidence.
Right. Thank you. How about Chinn and Jiayi? How do you see Spoton continuing on after the COVID-19 is over?
So I think like any software, there's always a version 1 and 2 and so on and so forth. So we certainly hope the COVID-19 will be over very soon. And one of the key things that we have for Spoton is the ability to do other things. As you have seen in the coming work, looking at density, looking at ability to actually look at pose, right? So when you talk about pose, it's basically a human figure and whether the person is lying down, sitting up, and so on. So when we make this kind of technology available, you can even put it into homes where elderly live on their own. So without betraying the personal identifying information, you may be able to position this camera, whether the person is lying down too long, or the person has moved, or the person has fallen, and so on. So the ability to do other things with it. A lot of it is using the technology which is already within the hardware, one that is temperature, the other one being the camera. So a lot of things can be done with the video feed. And then as Jiayi has mentioned, the technology and processing is now becoming so powerful, like you see on a phone. And it will not be long before cameras are as smart, the thermal capabilities will be much, much better over time. And then there'll be more talented engineers that will come out with ideas when another challenge comes up.
Okay, thank you. There's another question from the floor, maybe for Jiayi. It says, is there a challenge to align the EO image and the LIR image? And does it rely, does the face detection done on the edge, does it rely on pre-trained co-processors like Intel Movidius?
Oh, okay. Yeah. The challenge to align is not really a challenge. I mean, it's just getting to camera intrinsics and doing the right thing. So yeah, it's not that bad. The inference part, that's actually what I mentioned before. Because we're using ONNX, there's actually lots of ways to do the inference. You don't actually need to rely on specialized like TPUs or the like Movida stuff, even if you could if you wanted to. So here's the thing. There's a misconception where people say, oh, if I have a trained neural network to doing inference, I need to have a specialized GPU or TPU or whatever. That's not actually true. That actually depends, again, on how deep your neural network is and how many layers you're using. If your network is, well, deep, but is, it's not that heavy, chances are actually you might be better off just running it on a CPU. So you really need to make these performance trade-offs, understand the performance trade-offs before you actually decide what backend to run. Yeah.
Right. Thank you. And okay, so a couple of questions here for Han. How do you envisage the online testing solution to be like?
I think today the ability to solve home testing, that comes with chemistry, that comes with logistics. I think the big question from what I am visualizing is how do we achieve a better surveillance, not just necessarily in Singapore, but across the region, because no country will be at peace so long as there is one country where this is still active. And I think we all have a sense of a duty, a sense of the need that for there to be control in the region. And I think the ability to connect geographic information, the ability to visualize how these viruses, the mutation frequency, the genomic information, how this turns over, connected with online knowledge that will allow for a bird's eye view of this pandemic. And that's the connection between the offline and the online.
Right. Yeah. Talking about how much information there is, there's another interesting question. How much data would be generated from just one person's saliva sample?
It's very much up to the testing solution, but I would say that it can be as, and I think there are many software engineers in the audience. The amount of information in one coronavirus genome is about 30 kilobases. The actual test is about 200 bases. And so this is the difference between saying to be or not to be, that is the question. And we all know where that came from. That came from Hamlet. There is a big difference between just searching out that characteristic sentence versus reading the Hamlet over and over again. The amount of information we obtain from each saliva sample can vary because that is mixed with human samples, and the human genome is about 3 gigabases. If you introduce an error rate into that read, for example, 0.1%, and so in 3 gigabases, you would regularly get 3 million errors. And so in order to reduce these errors, you would have to oversample, and that would mean you might have to read the same genome 1,000 times. So from 3 gigabases, that therefore becomes multiply that by 1,000. And that could be the amount of information from one saliva sample, if you want to. Or do you really just want to be or not to be, to find out if there is coronavirus there? And I think so there is a choice depending on the application, but it can be very broad or it can be very narrow.
Okay, interesting, thank you. We'll have a few other questions, maybe like for all three of you to answer. What do you foresee as new challenges posed by the coronavirus and the constraints of this circuit breaker? What are the new tech challenges that you see have come out of it? Maybe Chinn and Jia, you can go this time.
Yep, sorry. Go ahead.
Chinn, you can go ahead first. I'm reading through your questions. Let me go ahead first, Chinn. I'm reading through
Okay,
your
so
questions.
maybe I'll ask you, Ming Li, what's your expectations?
What do I see as new tech challenges?
Yeah, what you expect when you think that challenges are out there that people like us need to try to solve? So I'm gonna put you on the hot seat a little bit.
I think, something that's close to my heart, food supply. Getting food delivered to me every day is something that I don't look forward to thinking about.
Right. I think that's a problem that everyone can identify. So if you're thinking about technologies that's going to be able to help us at this immediate time, I think exactly as you have said, right? Food security, the sense of how to feed ourselves, the fact that we have good internet, that we can have this conversation, the fact that we have access to clean water at our homes, and the fact that we have good medical health care when we need it. So these are all very important parts of having a safe environment that we live. Where technology can make a significant play, I think, is when GovTech began the digitization and became a digital government. I think that already allowed for a lot of things we can actually do from home. Imagine that we don't have to go down and get a lot of things done and transacting with the government. So from my colleagues that's working on the national digital identity, working on the moments of life, working on a Ministry of Education, and so on and so forth, right? So all the good work that has already been thought through and then put in place for actual events like COVID and the circuit breaker allow us to actually carry on running of the country and being able to even get access to medical help through telemedicine and so on. And so this gives us some comfort that we are actually thinking way in advance, many years before this happened, to put in place the infrastructure and the digital services to make it possible. Now, the challenge is, given that we are in this kind of situation, how does that change the way we work? How can we then think ahead in advance the technologies that we need to look beyond that is just digital? And in some ways, loop back again, because we live in a cyber physical world. We can't eat a virtual burger. But again, when it comes back to the human touch, so those questions will start popping up. How do we then connect that we are now doing as obviously through a conference call and broadcast, but how do we reconnect back to a community to allow for that that sense of community again? So these technologies have to start thinking along those lines eventually.
Not forgetting as well, the economic impact that the virus will have on our citizens, not forgetting those in lower income. And Han, would you like to share about, how do you think MedTech has helped people in less fortunate countries?
Well, I would say I look at that question a little bit differently, in the sense that there have been over 100,000 deaths from COVID-19 in the last few months, and that's a really sobering, somber figure. At the same time, there have been 2 million deaths from cancer. And cancer doesn't know this is COVID-19 time. It still happens, right? So I think the challenge is going to be, how do we manage the normal life? And I think today we are looking very closely at ICU utilization. How do we ensure that COVID-19 doesn't squeeze out the concurrent, equally important priorities? And really, this is where the public sector, the private sector, and policy making come together to ensure that society adapts well, and and we can keep calm and carry on.
Right. Thank you so much. We have other questions regarding like the process. I think a few people are not a few people are quite interested in the quick turnaround time of coming up with these solutions, both Spoton and the saliva testing kit. But from what I've heard from both GovTech and Lucence Diagnostics was that something in Lucence, in Han's case, it was just about readapting something that you already developed for Zika. And then in Spoton's case, it was because Jia has extensive experience in computer vision and AI and machine learning. Is there the question has jumped. Where has it gone? Yeah. Were there any organizational, operational challenges, and what were the sources of support that you had, which helped you to mobilize your existing resources to make these quick pivots? Jia, you want to talk about that?
Sure. Actually, we didn't get much support, and I think in those cases, that's the reality. We didn't actually get much support, but it's actually a good thing. So I actually firmly believe that the more constraints you have and the more hurdles you have to overcome, it actually forces you to think outside the box. It's kind of a bad metaphor, but that's true. If you have, I think a good analogy is, in my previous life, I was when I was an R&D technical director at Pixar, we had this joke, which was, well, I don't know if everyone agrees, but Star Wars Episode 1, 2, and 3 were terrible. 4, 5, and 6 were great. Why was that? Because 4, 5, and 6, George Lucas at that time, he was, he's starting out to make movies. So he wasn't known at that time. So he was working within constraints. He didn't have that much money, blah, blah, blah. He made it big. He had lots of money. So for 1, 2, and 3, he could do everything he wanted. He had all the money in the world. He could do whatever hell he wanted. But because of that, there were no limits and no constraints, you actually lose sight of reality, and you lose sense of what needs to be delivered and what's, what you cannot deliver. For Spoton, we are on a very tight time schedule. We have very limited resources, but that I think actually spurred the team on to actually deliver something, because we wanted to prove ourselves. So sometimes the opposite is actually better than giving you all the support. So that's what I believe in.
Okay. Chinn, anything to add?
Well, being a guy who is responsible for resources and all kinds of good stuff for the team. Yes, constraint is always something we have to live with. And I'm sure Dr. Mihan will share with you that, he must have struggled over the lab and did, I don't know how many experiments, probably more than Edison, right? Before he could make the bulb. But likewise, when it comes to software, I mean, it's blank slate, right? Everything is open. It's just a white canvas. You got to figure it all out. So you don't want to paint it in such a way that it jumps out of the canvas, because then you end up solving something you weren't meant to solve, and then you actually the opportunity to go and use the right resources in the right time in the right place may be blown. So what's actually going to be critical for some of these things is actually we are very clear what that problem is. We didn't go in not knowing what we were trying to solve. We went in with a very simple thing. How do we actually take the temperature of masses of people in a convenient way? Because you can imagine sticking a thermometer on somebody's forehead, and then sometimes you're fumbling, sometimes you're getting wrong results and all that. It's going to be quite tedious, and then the queue get longer, right? So imagine you had that 1 meter distance between the guy in front and the next, and so on. So that was a very clear problem, and so we had also the urgency to get it solved fast. So that helped a lot. I think what is most important is the management basically say go and try. So what if you fail, right? So at least we gave it a shot. I deliberately told the team you got to get it out in a week, because longer means we actually might have to look at other solutions. But because they were able to pick it up from whatever is lying around in the lab and then pull something off, that made it more awesome. Yeah,
it sounds like pure creativity.
Yeah.
How about Han? What was your experience?
I think I found the experience, it was actually a very profound experience, in the sense that this was almost a pivot for our company. And you must remember, the mission of our company was to achieve zero avoidable cancer deaths through technology. We didn't imagine ourselves, responding to the coronavirus pandemic. And so it was a very hard decision. This goes down very to the core of the mission and to our staff, our board, as to whether we wanted to whether we were able to pivot and bring our unique skills to fight this battle. And I think I'm very proud of the team. I think there is a certain mindset among people in technology companies, that there is a battle to be fought. There is, of course, a war to be won, but right now, I think because of the unique skills in chemistry and biology and in molecular diagnostics, and we do very well in the United States and Singapore in cancer diagnostics. But phrasing that to the team and phrasing this to the people around me, to the board, to our customers, that we would focus, wholeheartedly on this challenge in front of us. I think that was non-trivial.
Okay. That's a great answer. Thank you for sharing your experience with us. We have time for like one last question. It's really hard to choose among so many questions. Maybe if there's a bit of time later, the speakers can also go through it and type in some of their answers to some of the more interesting questions. Let's see. Is there any a question in particular that jumps out at you, at any of you?
I think we can give the mic to Han because I see quite a few questions for him.
Yeah, there's quite a number of questions on the saliva testing kit. I think there's one pretty interesting question that we haven't managed to answer yet, Han, is someone has asked, with FDA approval, does it mean that the COVID-19 test using saliva is something we can do in Singapore, or does it still need HSA approval? And is this test kit already in mass production?
So this is a question on local regulation. What I will say is obviously all health authorities are looking very closely at COVID-19 testing. I think all credit to the Ministry of Health and HSA for accelerating review and approval. What I'll say is I think today we recognize that in the right setting, especially for patients with symptoms, that swabs today remain the preferred approach to diagnosis. As alluded to earlier, different types of samples are going to give different answers. And I would say this is really something that doctors in our public and private sectors are looking at very closely now. And I expect, that the answers to this question can change very, very fast. But I think, as always, we want to respect best evidence and the data that's being generated. I would say different countries have certainly derived different answers to this question.
Okay, thank you very much. Does anyone have any last words, final words, before I hand back the time to SGN? Okay, if not, thank you very much for your time and taking your time and effort in preparing this presentation and sharing with us. I will pass the time back to SGN now.
Thank you. A very heartfelt thank you once again to our speakers, Han, Chinn, and Jia, and of course Min Li for helping to moderate our session tonight. The questions came fast and furious. We weren't able to answer all of them, but hopefully, we heard so much tonight, and we hope each of you took away valuable insights as well as inspiration. If you'd like to stay tuned to more of such content and to take part in future events, we've included the QR codes to sign up with SGN, Tech Plus 65, and of course, StackX meetups.